Hi everyone, this is Zakir and this is the 12th video in our module Matrices. Check the description below if you missed the previous video. And in this video, we will be discussing the properties of determinants. The properties discussed here can be used to simplify and ease the calculation of determinants. So let's start off with the basic properties. The determinant of an identity matrix is always equal to 1. And if any row or column contains only 0, then the determinant of that matrix is 0. And if any two rows or any two columns are similar to each other, then the determinant is 0. In this matrix, the first column and the third column are the same. So the determinant is equal to 0. The determinant of a matrix, say A, 2, 3, 4, 5, the determinant is minus 2. The determinant of its transpose, 2, 3, 4, 5, is also minus 2. So you can say that the determinant of a matrix and the determinant of its transpose is equal. Consider these two matrices A and B. You may notice that these two rows, the first row and the third row, have been interchanged in B. And when we find the determinant of A, we get negative 15. And the determinant of B is plus 15. So we can say that when we change any two rows or any two columns of a determinant, then the determinant changes its sign. Determinant of A is equal to negative determinant of B. Let's take this matrix A, 1, 2, 3, 2. The determinant of A is negative 4. Now let's find the inverse of A. That would be 1 over determinant multiplied by the adjoint of A. Finally, we get the inverse as minus half, 3 upon 4 and minus 1 upon 4. So the determinant of this inverse we get as minus 1 upon 4. So finally, we can conclude that the determinant of an inverse is equal to the reciprocal of its matrix. Consider these two matrices A and B. The determinant of A is 4 minus 12, that is minus 8. The determinant of B is 12 minus 2, that will give us plus 10. So the determinant of AB, that is A multiplied by B, is minus 80. If you see closely, when you multiply minus 8 into 10, you get minus 80. So we can conclude that the determinant of AB is equal to the determinant of A multiplied by the determinant of B. Next, we come to a very common simplification. Let's take this matrix A, 4, 5, 6, 8, 4, 2, 9, 12, 3. So the determinant can be written in this form. If you see closely, in the second row, 2 is a common factor, and in the third row, 3 is a common factor. So in a determinant, if there is a common factor in any row or any column, we can simplify by taking that common factor out of the determinant. So we can take this 2, we can take 2 out of this row, we get it out. We can take 3 from this row and multiply it by 2, and we can simplify this matrix to 4, 5, 6, 4, 2, 1, 3, 4 and 1. So that we get 6 multiplied by this determinant, that is 47. So we get the final answer 282. This is very useful when you have large numbers, and Don't confuse this with the simplification of a matrix. When you simplify a matrix, all the elements must have the common factor. But when you simplify a determinant, only one row or only one column is sufficient to have the common factor. So next we move on to the final matrix, the upper triangular matrix. Finding the determinant of an upper triangular matrix is easy. You simply multiply all the elements in the major diagonal and you get the determinant. So the determinant of this upper triangular matrix is 4 into 3 into 2, 12 into 2, that is 24. So now for the tip of the day. When you are given a question regarding the determinant, don't start calculating it immediately. Take a moment and analyze the determinant and see whether you can simplify it. Initially, it might take some time to find the simplifications of a determinant, but with practice, that simplifications can be identified quickly, thereby reducing the time consumed. So with that, we wrap up this video. Please subscribe to our channel, like our Facebook page and share this video to anyone who will benefit from this video. If you have any questions or any topic that you find difficult to understand, please ask us in the comments below. We are always ready to help you. Until then, take care.